All right, so welcome to Unit 2, which is all about atoms. And so, yes, we're going to be talking about the atom as we know it today. But before we do that, we're going to have to pick up where we left off in Unit 1 with regard to the history of the atom. So to recap, if you remember in Unit 1, we started talking about Democritus, who lived around 400 BC. And Democritus, through pure philosophical thought and reasoning, he had no library information of chemistry. He was one of the first real thinkers as to what makes up matter, right? And he coined the term atom. He had no colleagues. He had no scientific equipment. Again, it was just purely through thought and reason. And he came up with a very good, and for its time, relatively accurate model or theory with regard to the atom, right? And then after Democritus passed away, you had Aristotle, and he pretty much trashed all of Democritus's work. That is, he didn't adopt the idea of an atom and the atom arranging itself, or atoms arranging themselves in certain ways to form certain properties. He believed in the four essences: earth, water, air, and fire, and you could combine those in any specific way to create and to model any, anything that we can observe, such as fire or hot or wet or dry or so on and so forth. It makes no sense. And unfortunately, after Aristotle passed away, his theory, rather than Democritus's theory, prevailed for a long, long time. And of course, during this time, we had the Dark Ages, right? You had the Catholic Church persecuting scientists. That is, if you don't believe in the Bible, and you don't take it 100% literal, then you are blaspheming. And, they would persecute and they would put to death. And we're going to talk about that in just a little bit. And, of course, it's not that way now. Also, during the Dark Ages, you had the plague, right, which killed a lot of people in Europe and all of that. And you had alchemy through all that and before, which is not a science, it's a craft, where people tried to make something that had value from nothing, that had no value. And obviously, you can't do that. No one ever succeeded, but they kept on trying. So, because Democritus' theory was not adopted and Aristotle's was, plus the turmoil in Europe, scientific progress was halted for a long, long time. So what we're going to do now is kind of pick up where we left off, and we're going to talk about the rebound that science certainly made. All right? This is a picture taken in 1927, and obviously it was taken in black and white, but it was remastered. And these are, and the title of the image, 29 Scientists Who Changed the World. Now, these were not the guys that brought us out of the Dark Ages, right? That was about 300 years before, but these guys are sort of the modern age scientists. And it's just a great way to begin. By the time we complete this course, you're going to be familiar with a large majority of these scientists. And notice on the front row to the left, you see the one and only female in this picture. And you're going to learn about her in this unit. And man, she was a fantastic scientist and really, really paved the way to progress. All right, so let's go ahead and talk about kind of a timeline here, and you're going to be expected to make your own timeline later on. And so we talked about Democritus and Aristotle, and right now we're kind of in this in-between, kind of in this gap. And so let's pick up during the Dark Ages, all right? So during the Dark Ages, again, I told you had alchemy, which was nothing new. You had persecution and by the church, and you had the plague, right? So let's talk about some things that went on during this time. We're going to focus on somebody that you've heard of for sure, and that is Galileo. Galileo was an Italian astronomer and physicist. He was trialed and convicted in 1633 for publishing evidence that supported Nicholas Copernicus' theory that the Earth revolved around the sun. His research was instantly criticized by the Catholic Church for going against essentially what they believed to be true. That is, Scripture that they thought anyway placed the Earth and not the sun as the center of the universe. He was found of heresy for his heliocentric views, that is, the sun being the center and not the earth, and was required to pretty much admit he was wrong and they're right. He was sentenced to house arrest, where he remained for the rest of his life, and his offending texts were banned. All right. He was acquitted, by the way. That is, he was all of his charges were dropped against him. But the problem was, this was in 1633, and he wasn't acquitted until 1992. But at least it was done. But again, this was some of the things going on during the Dark Ages. So there were some events that led to the Enlightenment. So the scientific revolution and its challenging of the church's ideas were followed by a period of enlightenment where people not only questioned the church's ideas, but also began to question the church's authority. That is, why can't we believe in God and science at the same time? Now, to be clear, you can't say these scientists were atheists back then. I'm not trying to go either way on that, but these scientists were not saying forget the church and forget religion totally, at least not all of them. They were like, why can't this go hand in hand? Using some common sense approaches. These periods of challenging times eventually led to the prominent holdings of liberty, progress, tolerance, and scientific theories within the church. In other words, these scientists kind of said, you know what, we're gaining quite a following. They got more manpower. They were able to overcome. And again, over time, the church started to modify their extreme beliefs and were able to kind of start coinciding with these scientists and their factual research. And one of the scientists who really paved the way throughout the Enlightenment and led to the scientific method was Antoine Lavoisier. And there's a picture of him and his wife here. And by the way, his wife was really more important than he was. You see, Lavoisier was not only one of the first quote-unquote true scientists, but he was also a supporter of the French Revolution. And in 1794, he was guillotined, meaning he had his head cut off, right? The thing is, his wife was bilingual, meaning that she knew more than one language. And so when Lavoisier passed away, she was able to take his work, and by the way, she was a scientist also, so she understood his work. She helped him with it, and she was able to translate it into other languages where people across the globe, or at least more people across the globe, could see the progress that her husband had made. So she is quite the lady also, and very helpful to her husband. But again, Lavoisier is kind of the guy that is the bridge between the Dark Ages into the Enlightenment. Now, by no means is he the only one, right? You just saw Galileo played an instrumental role. But we're going to focus on Lavoisier, all right? He began using what we now call the scientific method. The scientific method was kind of created over time once people in Europe and other places felt freedom to conduct genuine research without persecution. Because bias, by the way, my friends, is the number one enemy of science. And of course, these founding fathers of science figured that out because they just moved from bias of the church, and they sure didn't want bias in their own field. And so they came up with a scientific method that ensured what they done was factual and truthful, something we need to move back to today. What does the scientific method do? Well, it allows you to collect data via experimentation and analyze that data to create facts. One of Lavoisier's biggest scientific achievements was the law of conservation of mass. You know that, right? Matter is neither created nor destroyed. And he's known for this as the father of modern day chemistry. And that's certainly an important last bullet point that you will see again, hint, hint. All right? The scientific method is just integral, right? You've got to know it. Chemistry is based on, and all science, by the way, not just the subject of chemistry, is based on observation and experimentation. Over the last few centuries, the scientific community has developed procedures to explain phenomena to the highest level of accuracy. Again, before the Enlightenment, you had all of this bias toward religion. And again, I'm not saying that's a bad thing. I'm a religious person. But you see how extreme it was taken back then. And the scientists who kind of led the way to bring us out of that movement did not want some other form of bias to creep into science, right? And by the way, I would argue that unfortunately that has happened today, as you have probably heard and seen and witnessed with all of the quote-unquote factual information that we've been given from certain organizations as a result of the coronavirus. But I digress. Science's worst enemy is bias, and this will be on the test. Which, by the way, the definition of bias is injecting your opinion. In other words, skewing the data to say what you want it to say, or to achieve the certain outcome that you want to have, instead of really discovering what the truth is, what the facts are, right? But the scientific method, if used properly, prevents this from happening. So what I would encourage you to do is anytime you hear some information, Ronald Reagan had, one of his most famous quotes, trust but verify, right? Because unfortunately, a lot of quote-unquote scientists today, in my opinion, are kind of moving back over to that bias position that was prevalent in the Middle Age times, the Dark Age times, and they're using or injecting their own bias instead of using the scientific method to really show what the truth is. So anytime you read something, I would just encourage you to verify it, right? And just be sure that you're not being indoctrinated by some quote-unquote scientists' views and opinions. In other words, trying to skew things to say what they wanted to say, whether it be for a financial or a political kickback. But again, verify it to be sure that it is truth in this day and age. And that's so unfortunate because, science up until recently had this great reputation of just being plainly apolitical, factual, and truthful. And now we're moving away from that. And it's a sad, sad thing. All right? So anyway, I hope you have enjoyed this little lesson. I'm very passionate about this. And I would just encourage you to do some of your own research and always, always trust but verify. Especially verify.